Dear students, in this class we are going to discuss about unimolecular nucleophilic substitution reaction. Before start this topic, I would like to give some tips. So please don't skip this lecture. If you want to understand the complete essence, you need to listen this video lecture until the end. Okay. In the last class, we learned about the SN2 reaction and the factors affecting the rate of reaction. So these are the key steps. The nucleophile attack the halogen connected carbon from backside. Okay. And bond forming and bond cleavage happen simultaneously. And this is SN2 because the rate of reaction depends on both the reactants, that is nucleophile and the alkyl halide. So these are the summary of SN2 reaction. What are the key points we learned in the factors affecting the rate of SN2 reaction? So we discussed 4 factors. One is the nature of alkyl halide and the nature of nucleophile and the nature of leaving group and nature of solvent. In the nature of alkyl halide, so we learned the tertiary alkyl halide, it's very difficult to undergo SN2 reaction. So this is a tertiary alkyl halide. As we learned, the nucleophile always approach from the backside. Okay. The partially positive charge carbon. As we discussed, the factor of factors affecting the rate of SN2 reaction, if the alkyl halide is too much sterically hindered or bulkiness, so it will not allow the nucleophile to attack the partially positive charge carbon, that is halogen connected carbon. So these groups will create the steric hindrance. Okay, so this will not allow the nucleophile to attack this one. As a result, this reaction is not possible by SN2 mechanism. Okay, but what we are aiming is we want to synthesize this compound from this starting material. Okay, how we can achieve this transformation? Let us discuss one by one. Now, the first point is steric hindrance. So this will not, the nucleophile will not attack the partially positive charge carbon. Okay. So the steric hindrance. So how you can clear the steric hindrance? So if you break this one, the halogen by heterolytic cleavage, so that hindrance may be reduced, and it forms carbocation like this. Like this it formed. So please remember, in the SN2 reaction, both the bond forming and the bond cleavage, that is the nucleophile attacking the partially positive charge carbon and the halogen connected carbon breaking simultaneously. Okay, but in the tertiary alkyl halide, the nucleophile is not possible to attack this partially positive charge carbon. So what it happens? The halogen connected carbon is getting broken. It gets cleaved by heterolytic cleavage mechanism. So and it forms carbocation. So this is the first step. Okay. And you see, I put this one in the equilibrium. You see, the forward reaction is slow, and the backward is fast. Why the forward reaction is slow? Because this is the starting material is almost not neutral. Okay, this is neutral. Now this became a charged species. Okay, charged species. That's why it is not ready to break this full-fledged, this charged species. That's why this step is very slow. Clear? Now we assume, however, this carbocation has been formed. Okay, and in the second step, the carbocation is attacked by the weak nucleophile, like you take the water. Like you take the water as a weak nucleophile. So the lone pair electron of the oxygen attack this, or not the attack the carbocation carbon, and it forms this product. Okay, like this, like this, like this. That oxygen will get a positive charge because it lost its lone pair, and finally that hydrogen lose its electron to stabilize the positive charge of the oxygen. Okay. So you get like this. So this is the reaction is formed. The product has been formed. Now you see, so first step is the carbocation is formed. The second step, the carbocation is attacked by the nucleophile. Here we use generally the weak or neutral nucleophile. Weak or neutral nucleophile. And we will discuss why the weak or neutral nucleophile in the factors affecting the rate of reaction, SN1. Okay, now this is the rate determining step. This step is a rate determining step. In the rate determining step, the carbocation is formed. If the carbocation has not been formed, the nucleophile won't attack it. That means the rate of reaction depends on only one reactant, that is alkyl halide. Okay, alkyl halide. The rate of reaction depends on alkyl halide. So why this reaction is called as unimolecular nucleophilic substitution reaction. But in the SN2, the rate determining step, both the nucleophile and the alkyl halide has been involved, but here only one reactant, that is alkyl halide, has been involved. That's why the rate of reaction depends on only one reactant. So we call it as a unimolecular nucleophilic substitution reaction. Okay. The next, we should discuss the factors affecting the rate of SN1 reaction, that we will discuss in the next class. See you.